Welcome to Nuance of Neurons, where we embark on an exciting journey, unraveling the patterns that construct the reality we perceive around us. Can we truly touch anything? Or is it just an illusion, a perception created by our brain? To explore this question, we first need to delve into the fascinating world of atoms. Everything we see, touch, or interact with is composed of atoms, minuscule particles forming the building blocks of the universe. When two objects observe what could be considered touch, it's essentially an interaction between the atoms that constitute these bodies. Let's think about what happens when you touch a table. Your fingers never physically connect with the atoms of the table. Instead, they are repelled by the forces present between the atoms. This repelling force is what your brain perceives as a solid object, which we refer to as touch. The interaction is not really physical. Surprising, isn't it? It's actually electromagnetic forces at play presenting themselves as what we perceive as touch. It's just like two magnets. They can push or pull without any physical contact. So we never really touch anything in the physical sense. It's the forces that interact. This is the magic of quantum mechanics. Do you feel your understanding of touch altering already? We are so accustomed and intuitively wired to this force interaction that we recognize it as touch, a sensory perception. Stay tuned as we probe deeper into this question, grappling with the essence of reality around these forces. In a quantum realm, particles may behave bizarrely, being in multiple places at once, and even change their state due to observation. Right now, we are entering the uncharted waters of quantum mechanics, a theory that doesn't relate to the touch we perceive. On a quantum level, those forces we acknowledged as touch bear no semblance to our comprehensible push and pull. Imagine an electron spinning like a top. What happens when we look at it? Observing in quantum mechanics can actually alter the state of the spinner, making it decide its position once and for all. Funny how that works, isn't it? The very act of observing alters the reality. Quite a quantum conundrum. This is what we call superposition. A particle existing in all states at once until observed. These phenomena defy our usual sense of touch and interaction. It's not what we identify as physical contact. Quantum world kind of breaks the rules. It's like pressing a key on your piano and hearing a flute playing. Just like Schrödinger's cat experiment. The cat is both dead and alive until you open the box and observe. Our concept of touch can't fully encompass these peculiar demonstrations in the quantum world. These tiny particles were composed of play by the quantum rules, far removed from our perceptible reality. In simple words, we living in a touchable world are nonetheless made up of untouchable particles. Isn't it crazy? Yet it beautifully exemplifies the realm of quantum mechanics and the stark difference between our macro experiences and micro interactions. So next time, when you touch something, just remember it's only a perception, an intimate dance of forces around us. Consider that every time you touch something, what you're really feeling is the electromagnetic force resisting you. The atoms in your hand are repelling the atoms in whatever you're touching, creating the sensation of touch. Remember, quantum mechanics remains the most precise scientific theory ever conceived by human understanding to date. Yet it's counterintuitive and sets our daily life perceptions and its fundamental rules in stark contrast. We've explored such quantum phenomena as wave-particle duality, quantum superposition, quantum entanglement. They certainly defy our everyday logic. Think about it. The universe at its tiniest is governed by rules that are wholly different from what we experience. Such understanding possibly underscores the limitation of our human awareness, shaped by our perceivable reality. As astonishing as it may seem, this strange realm of quantum mechanics is fundamental to our existence. Next time you touch anything, remember, you are not really touching it. It's more about electromagnetic interaction. Thus, our familiar tactile world is just a perception and a deeply fascinating aspect of quantum mechanics. As we explained earlier, observation in quantum theory can alter the reality. It's the observer effect in action. Evidently, our observations shift the state of quantum particles. Just by watching, we alter reality. And that's just a glimpse into the enigmatic world of quantum mechanics, where every touch is a universe happening. Our macro experiences cannot capture these peculiar micro-interactions, thus creating an illusion of separateness between us and the world. At last, in the realm of the infinitesimally small, we find a beauty and interconnectedness beyond human perception. Indeed, everything we perceive is essentially a play of quantum particles following an intricate dance. Remember, we all are part of this grand cosmic ballet, intricately woven into the fabric of time and space. So now you see, the universe isn't just stranger than we imagine. It's stranger than we can imagine. But that's where science and insatiable human curiosity comes in, to slowly unravel the mystery piece by piece. We hope that these insights into the paradoxical wonders of quantum mechanics have sparked your intellectual curiosity. Regardless of how counterintuitive it seems, capacity to ponder upon these mysteries makes us uniquely human. And as we part ways for now, remind yourself, when you reach out to touch something, a universe happens. Thank you so much for joining us on this journey into the quantum world. Don't forget to subscribe for more.